Okay, so I want to start with just a brief introduction to section 1.6, substitution and exact equations. And there's, I mean, you're going to read the book because some concept questions, right, you're going to be answering from the book. But there's a lot going on in this section, and I'm hoping to break it down. So one thing about this section, just briefly, is you may find this section perhaps to be relatively challenging slash frustrating if you're not familiar with these techniques. But I'll try my best to be as clear as possible. Again, just from teaching this class many times, and also it's really just practice this section, and again familiarizing yourself with these techniques. So one of okay, let's just kind of big picture here. So the kind of big goal of this section is we're going to look, or you're going to look for special forms, right, of differential equations. And I mean, this section really is practicing on familiarizing yourself with these, techniques of transforming, a differential equation by substitution. So, okay, big picture. So dy, we've been starting with, right, dy dx equals f of xy, right? So a function of x and y, right? And recall this is our first order differential equation. And in section 1.4 and 1.5, we learned how to, solve a differential equation by either separating the variables, right? It's a separable equation. That's what we did. Or sometimes in section 1.5, right, it was a linear first order differential equation, and so we used our integrating factor, right, multiplied both sides, and so forth. So we've learned how to solve this type of differential equation by separating variables, right, or using the technique in 1.5 if it's a linear first order differential equation. So the question is, what if it's not separable? So what if our differential equation is not, right, separable, or linear for that matter, right? What if we can't separate the variables, and what if we can't find that integrating factor? And there are times where you're not going to be able to, so what do we do next? Well, that's why we have 1.6, right? Because we have this technique of a substitution method. So I'm just quickly going to write this down, and then I'll start doing examples in the next video. Okay, so we have, again, dy dx is f of xy, and the goal of this section is hopefully to, well, I mean, if we can separate the variables, is to transform, right, our differential equation to this form, dv dx, right, and it's going to be a function, right, of x and v. So instead of v, or that's an x, instead of x and y, let me write that as an x, instead of x and y, because we probably can't separate the variables, right, we're going to try to substitute, we're going to use substitution, and we're going to rewrite the differential equation, right, in terms of v and x here. And here, of course, v is the dependent variable, and of course here y is the dependent variable. So that is kind of the big picture, right? And by maybe substitution, right? And this section is also called exact equations. I'll go ahead and talk about that a little bit later, but because in order to understand what, or in order to solve exact equations, we need to understand these methods of substitution. So let's practice. I'll go ahead and do an example in the next video.